Hello everyone, my name is Matthew Milkovich, and I'm here to talk to you about solid-state batteries and why they are so beneficial to society in the next upcoming years. So first I want to talk about why so many devices end up going up in flames, and we all know it's because of the battery, but what about the battery is the issue? This issue is not only because of the condition of the battery. Major companies like Tesla, as you can see from this burning car, Samsung, as you can see from this burnt phone, and even the hoverboard craze, they all caught on fire, and they're all respected companies. So what was the issue with this specific battery? The problem is all these devices have lithium ion batteries with liquid electrolytes that are flammable. So what happens is the lithium ions move too fast. The rate at which a lithium ion battery charge is carefully limited so that the lithium does not move too quickly, which incidentally is why batteries take so long to charge. If it moves too fast, lithium plates begin to form around the anode, creating a short circuit and generating heat. The heat, if it builds up, can ignite the flammable electrolyte, and you've got your battery on fire, as we've seen from our examples. This is when solid-state batteries come into play. And the only difference between solid-state battery and a lithium-ion battery is a lithium-ion battery has a liquid electrolyte and a solid-state battery has a solid electrolyte. To understand the difference between the two, we first need to understand how a lithium-ion battery works. So as we know, a battery is made up of an anode, cathode, separator, electrolyte, and two current collectors, both positive and negative. The anode and the cathode store the lithium. The electrolyte carries the positively charged lithium ions from the anode to the cathode and vice versa through a separator. The movement of lithium ions creates free electrons in the anode, which creates a charge at the positive current collector. The electrical current then flows from the current collector through a device being powered, such as a phone or computer, to the negative current collector. The separator blocks the flow of electrons inside of the battery. Now I'm going to briefly explain how a lithium-ion battery charges and discharges. While the battery is discharging and providing an electrical current, the anode releases lithium ions to the cathode, generating a flow of electrons from the one side to the other. When plugging in the device, the opposite happens. Lithium ions are released by the cathode and received by the anode. The two most common concepts associated with batteries are energy density and power density. And to make it easier, I will use the analogy of treating a battery like a pool. Energy density is measured in watt-hours per kilogram and is the amount of energy that a battery can store with respect to its mass. Energy density is similar to the size of the pool. Power density is measured in watts per kilogram and is the amount of power that can be generated by the battery with respect to its mass. Power density is comparable to draining the pool as quickly as possible. We all know lithium ions can swim through a liquid electrolyte, but when it comes to a solid electrolyte, solid-state diffusion is necessary in order for the lithium ions to be transferred through the electrolyte. It's almost like the lithium ions play musical chairs with one another. As I said, lithium ions are going to act like musical chairs, so let's use the example of the compound lithium chloride. Lithium chloride is a solid, and as you can see right now, there are no places for the lithium ions to go, so there could be no diffusion of these lithium ions. So what we could do is we could get rid of some lithium to create a vacancy. But what that would do is create a charge imbalance in the crystal structure, which we cannot have. How can we kill two birds with one stone? To have a balanced crystal structure and have a vacancy for lithium ions to diffuse through the solid. The solution is to add an element with a higher oxidation state, such as a magnesium ion. As you can see from this example, 4 lithium ions were removed, but 2 magnesium ions are added. And because two are added, it creates 2 vacancies, but keeps the charge balanced. Solid-state electrolytes can use the holy grail of anodes, lithium metal, which is much smaller than the anode graphite used in lithium-ion batteries. It compresses the anode, cathode, and electrode into 3 flat layers instead of suspending the electrodes in liquid electrolyte. That means you can make them smaller or at least flatter, while holding as much energy as a large liquid-based battery. So if you replace the lithium-ion or lithium polymer battery in your phone or laptop with solid-state battery the same size, it would get much longer charge. Alternatively, you can make a device that holds the same charge much smaller or thinner. A solid-state battery could outperform conventional rechargeable batteries by 500% or more in terms of capacity and charge up in a tenth of the time. Solid-state batteries are also safer since there are no toxic, flammable liquids to spill, and they don't output as much heat as conventional rechargeable batteries. When applied to batteries that power current electronics or even electrical cars, you might recharge much faster too. Ions could move much more quickly from the cathode to the anode. Instead of electrolytes combusting like they can in lithium-ion batteries, you could literally cut some of the solid electrolyte out of the system or shoot a bullet through the electrolyte and the battery could continue to run flawlessly. If you have ever heard of the meme, me versus the guy she told me not to worry about, in the battery world, lithium-ion battery is you, and the solid-state battery is the guy that she told you not to worry about. My innovation with this new battery technology is to use it for military vehicles, and here is why. These batteries are now light enough and powerful enough to completely replace gas-powered military vehicles and overall run better than them. Let's say a bullet hits a gas tank. It will either make the gas leak out or it will make the gas combust, creating a fire or explosion. With a solid-state battery, it could literally have chunks of it removed or bullets shot through it and it would still be able to function. So do you want your country to be as safe and protected as possible? Then I recommend investing in my innovation so the Canadian military can keep you and your loved ones safe with solid-state batteries. The only downfall of solid-state batteries is that they are expensive to produce as of right now. If you invest in my innovation, we will be sure to research and find more efficient and cheaper ways of producing this elite battery. This has been my innovation project on solid-state batteries, and thank you for your time.